filter, if you introduce a filter, the target is to remove the noise, but not necessarily to remove the noise, but target is to remove the noise. And the engineering applications, normally the noise may caused by the measuring devices or something related or other disturbance signals. So there should be this kind of, the signal should be this kind of thing. So if you are trying to use a PID controller, you may not use it directly. Because if the real signal may be very smooth, however, the signal may have jump here. If you take derivative to it, it might be very dangerous. So in real applications, we cannot use PID controller to it directly. The better way is to filter the signal to make it smoother, and then use the PID controller to do it. So this is the noise, the signal. So our target is how to remove the noise. We cannot remove the noise completely. So in this case, we may introduce a filter and the discretized version of it is something like this, a phase transfer function. And so now our problem is how to select the coefficients in the function. And before that, I will show you the result of filter. If we introduce a filter like this, and this is a polynomial A over B. This one can be considered as a filter, and the detail of the coefficient are given above. So with the use of the filter, we can check what should be the filter result. And here I will explain detail of this later to you. So let's just see what is the filter result. This is the filter itself. Okay. I will explain this one later to you, how it works. You see, this one is the original signal, and you can see the green one. This one should be the filtered signal. I can remove the original signal first. So this one should be a filtered signal. It is smoother, but we cannot expect to remove all the disturbances. Let me draw the signal again. We can see that clearly from here, there is a delay caused by the filter. So this cannot be avoided. The delay cannot be avoided. So it can, to some extent, filter the original signal and remove some of the noises. However, there is a delay as well. So let's go back to the original problem. How can we design a filter? This is already an existing filter. I used it. So how can we design a filter? In Matlab, there are several types of filter which can be. Well, before this one, I think I have to explain something about the filter. Commonly, I have to present something about the commonly used filter types. This is a common form of a filter. If the if the numerator is 1, then it is called AR model. If denominator is 1, it is called AR model. And apart from that one, I think there are FIR model, finite impulse response, or infinite impulse response models. Okay, and I think that I got quite confused which one is which. One of them is with the numerator as 1, and the other one has a full form like this, I think. This one should be infinite. It should be a form like this. Well, if the numerator is 1, then it is a FIR filter. I myself get quite confused about them. Oh, here is a slide. So for m equals to 0, which means the numerator is 1, then we call it FIR filter. And for n equals to
okay, for the first one,
the problem.
Say for the first one, the numerator is 1.
Yeah.
Yeah, for the first one.
For the denominator, there's something wrong here. I'm not quite sure. Oh, there is a problem. So for IIR, it is an OPO filter. However, there should be a change of line here. For this case, for numerator is not 1, and denominator is 1. It is called auto-regressive AR filter. So there are certain forms. IIR for n and m are non-zero. And there are certain filters, for instance, Butterworth filter and Chebyshev filter. And for details, I think there is a filter design toolbox in Matlab. You can find it, I think. And for better details, you have to read the manuals for that toolbox. Okay, I think there is a filter design. Filter design toolbox. And here I want to give a simple demonstration of the filter design and what are the useful parameters in filter design.